Okay, this video we're going to look at resistors in parallel. So we've got our two formulas for resistors in parallel. We've got product over sum, so R1 times by R2 over R1 plus R2. Now that formula only works if you've got two resistors. If you've got more than two resistors, then you've got to use the 1 over R1 plus 1 over R2 plus da 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 da. So you can use that for the 1 over formula for as many resistors as you like. However, the result of this formula is given as a 1 over, so we've got to make sure that we then flip the answer. Okay, let's look at an example. So if we look at an example of 3 ohm in parallel with 6 ohm, then if we look at it in product over sum, 18 divided by 9 gives us 2 ohms. If we use the 1 over RT function, then a third plus a sixth equals a half. That's because then we need to make sure that then we do 1 over our answer RT, which equals 2 ohms. Okay, if we look at it again with a slightly more complicated, so 27k, 18k, and a 9k, then we've got remember to use the times 10 to the x button at the bottom of our calculator, so we can put in 27,000. That's how we do it, times 10 to the 3, so times 10 to the x button and then 3. So we're putting them as fractions in. We get our answer, remembering that then we've got to take 1 over our answer, giving us 4.9k. Okay. So we're now going to look at current flow in a parallel network. Well, if we place a voltmeter across our parallel network, we're going to have exactly the same voltage across each resistor because electrically they're at exactly the same point. So we're going to have the same voltage across each of the resistors. Now, if the resistors are different, then we're going to have different currents going in different ways. So we've got I1 and I2. So if we look at that's the example, 3 and 6 ohms with a 9-volt battery. Then the current I1, 3 ohms, so 9 volts divided by 3 is 3 amps, and then through the second resistor, the 6 ohm, we're going to have 1.5 amps. Okay, so it's the voltage across both resistors divided by the resistor value. Now, if we just take that one step on, we said that the 6 ohm and the 3 ohm simplified down to a single 2 ohm resistor. So if we look at the current flowing through that 2 ohm resistor, 9 volts divided by 2 ohms is 4.5 amps, which is actually the total current that is then feeding this circuit in the first place. So that's our I total that's then feeding both resistors.